Have you ever wondered how our brains process information, or how artificial neural networks, designed to mimic our brains, interpret data? The answers to these questions lie in the fascinating interplay of excitatory and inhibitory inputs. Imagine a bustling city, with countless messages and signals crisscrossing between its inhabitants. This city is a neuron, the basic unit of our brain and artificial neural networks. The messages? They're excitatory and inhibitory inputs, the unsung heroes of information processing. Excitatory inputs are like cheerleaders for the neuron. They encourage the neuron, saying, "You can do it, fire up." These inputs increase the likelihood that the neuron will produce an output, or in other words, they stimulate the neuron to fire. In the realm of biological neurons, this stimulation may involve the release of neurotransmitters that promote the transmission of signals between neurons. On the other side of the spectrum, we have inhibitory inputs. These are the neuron's cautious advisors, urging it to hold back. They work by decreasing the neuron's chances of producing an output signal. In biological terms, this might involve neurotransmitters that hinder signal transmission. Now, let's consider artificial neural networks, computing systems inspired by our brain's interlinked neurons. In this context, excitatory and inhibitory inputs take the form of mathematical weights. Excitatory weights are positive, amplifying the input signal, while inhibitory weights are negative, reducing the impact of the input signal. These weights influence whether a neuron in the network will spring into action or stay idle, based on the weighted sum of its inputs and a certain threshold. To sum up, excitatory and inhibitory inputs are the conductors of the brain's symphony and the puppet masters of artificial neural networks. They are fundamental to how neurons process information and play a crucial role in the functioning of neural networks, whether biological or artificial. So, the next time you marvel at the complexity of the human brain or the capabilities of artificial intelligence, remember the unsung heroes, excitatory and inhibitory inputs. They're the ones directing the show, making sure every neuron knows when to step into the spotlight and when to fade into the background.